Okay, in the next part of this chapter, we have three-dimensional problems. Okay, so they will give you three-dimensional problems, which is printed on a 2D surface, so you really have to be able to visualize the three-dimensional properties, okay, and angular properties in a three-dimensional figure. Alright, so in three-dimensional problem, this concept is very important. Okay, although this is printed on a 2D surface, we can tell that ABCD, this is a flat. Okay, this is a flat surface. Okay, to flat surface, we call it a plane. Alright, so this flat surface ABCD, okay, which is also technically called a plane ABCD, we have a vertical line XY. So this is our vertical. Okay, I hope you will be able to visualize XY. And this vertical line is perpendicular, forms a right angle with this plane. Alright, so in short, okay, the technical word for this vertical line XY is called a normal. Okay, normal is always perpendicular. Okay, normal means perpendicular to line or surfaces. Okay, to the surface, flat surface. Okay, or plane. Okay, I would prefer to use the word plane, okay, to describe flat surface. Okay, but I use the word flat surface so that you can relate, understand what is plane. Okay, technically the word to use is plane. If it is perpendicular to every line on the plane. Now this is a interesting property here. Okay, let me draw some straight lines. So if we have plane ABCD, we draw a straight line. Okay, multiple straight lines across. I don't want shadow. Okay, if I continue to draw, okay, I can continue to draw several straight lines into this. Okay, you will never stop. Okay, until all the lines can form this. Okay, you will see that all the lines, right, at different angle that I draw through this point Y. Okay, point Y, which is also perpendicular to this XY. Okay, so we can draw a lot of them. This XY will be normal to this entire surface. Okay, so that's what it means. It's perpendicular to every line on this plane ABCD. Alright, so this concept is important. Why? Because if, okay, in the situation, okay, where you have to solve for this kind of three-dimensional problem, okay, you will realize, okay, knowing this perpendicular, okay, you can actually form right angle triangles easily and solve it. So for example, if I have this line A to Y, okay, A to Y, alright, okay, and then we have another line, okay, from the top here, X to A. So you realize we have a right angle triangle XYA. Okay, then we can make use of our trigonometry ratio, right? Or in some cases maybe sine rule, cosine rule. But most often, since we have right angle triangle, we can use trigo ratio, our Tokaso, to solve problems. Okay, so now let's look at example 10. Right, example 10. Okay, so we have a triangular prism, which AD and AB are 3 cm. And D is 2 cm, ADE is 80 degrees. So we are supposed to find the length of AE. Okay, now in this case, we do not know if ADE is not a right angle triangle, so we can't use our Tokaso. So next thing that we consider, can we use sine rule? So the the information that we need to have to use sine rule, we need to look at this triangle. Okay, do we have one pair of opposite angle and side value? Okay, the answer is no, we do not have. Right, we are supposed to find AE. Okay, with 80 here, but we know this is 3, we do not know the angle. We know this is 2, we do not know the angle opposite of this 2, the side DE, that is 2 cm. So we can only use cosine rule to find AE. Okay, so AE equals to 3 square plus 2 square minus 2 times 3 times 2 cosine of 80 degrees. Okay, 80 degrees. Okay, so to find AE, we can square root, okay, what the calculator value that we get here, okay, which is 10.91. 622. Okay, so we square root this value to get AE. So on my calculator, I get 3.30397. So I round off to 3 SF for presentation. Okay, so I may also want to save this value in my calculator in case in later part of the question I will need this. Okay, so next, angle DAE. Okay, we are supposed to find this angle here, DAE. Okay, so now we can actually use the sine rule since we have gotten the length of AE in part 1. So this is opposite of AT. So for part B, we can use sine rule. Okay, so to form our sine rule, we have AE over sine 80 degrees, okay, equals to, we are supposed to find angle DAE, so we know DE is 2 cm, which is opposite of angle DAE, so 2 over sine of angle DAE. Okay, so as we shift the values around, so sine angle DAE will be equals to 2 divided by AE over sine 80 degrees. Okay, so we can calculate this using the AE value that we have calculated in part 1, which is 3.30397. So if you have saved this exact value in your calculator like I have done, okay, you can make use of the exact value to calculate. Okay, so I actually get 0.596135. So in order to find the angle DAE, okay, I have to inverse sine, okay, this ratio here. So my answer is 36.593. Okay, so round off to 1 decimal place because this is angle in degrees. Okay, 36.6 degrees, so 1 decimal place. Alright. Okay, so I also save this value in my calculator. Okay, the exact value in case later on in the calculation I will need it. So in part C, we find the volume of the prism. Okay, to find the volume of the prism, we can find this surface area. Okay, ADE, because this is a cross-section area. Alright, if we slice this prism across, okay, at different points, we will get this same area. So this is a cross-sectional area. So we find the area of triangle ADE and then multiply by the height, which is 3. Okay, we can get the volume of the prism. So in order to find this area, okay, what we can do, okay, we have enough information for half AB sine C. We have 3 and 2 and this angle C in between, so which is 80. So to find the area of triangle, okay, is our next step. So area of triangle ADE. Okay, we use half AB sine C, so half times 2 times 3 times sine of 80 degrees. Okay, and then what we can do here is that we can straight away write down the volume of prism equals to, the height is 3, so 3 times half times 2 times 3 times sine 80 degree. Okay, so you may want to calculate out this value, also can on your calculator, but After that, you got to use the exact value. Okay, do not round off. You use the exact value and times 3, which is the height of the prism. So our calculation, okay, I'll get 8.86326. Okay, so rounding off to 3 SF, 8.86 cm cube. Okay, cubic cm. So to 3 SF. Okay, so this is our answer to part C. Okay, let's look at part D. Alright, we're supposed to find the perpendicular distance of D to AE. Okay, so same thing here, D to AE. Okay, it's like the last question, example 9, last part in 7.2. So to find this perpendicular distance, we have already gotten our length AE. So this is actually half base times height. Okay, this base here is our AE. So this perpendicular height we are able to find. We have already got the area of this triangle in part C. So we make use of this area of triangle, which is what we have found here. Okay, over here. Alright, so we can form this equation. Okay, area of triangle, half times 2 times 3 times sine 80 degrees will be half times AE times perpendicular height. So AE we have calculated in part A. So we have saved it in our calculator. So later on we just need to make use of the value. Okay, so H, we shift all this value, half and half can be cancelled away. So H will be equals to 2 times 3 times sine 80 degrees over AE. Okay, so which is 3.30397. Okay, so on our calculator, okay, I get 1.78840. Okay, so round off to 3 significant figure, 1.79 cm. So this is the shortest distance. Okay, which is also the perpendicular distance from D to AE.